Last time we talked about Rawls theorem and mean value theorem. Rawls theorem says f is continuous on a closed interval and is differentiable on its interior. Suppose at the end point of this interval, f of a equals f of b. Then there must be somewhere the derivative of f is 0. For example, this is a position at c, f prime of c is 0, means the graph at this point has a horizontal tangent line. The generalization. In fact, we use Rawls theorem to prove this. So these two theorems are equivalent. Mean value theorem or the mean value theorem. We use this means they are some other mean value theorems. This is the mean value theorem for derivatives because f is differentiable open interval idea. In the future, maybe we have mean value theorem for integrals. But when we use the mean value theorem, we mean this mean value theorem for derivatives, because we have this condition, f is differentiable on the open interval idea. Okay. Again, under very gentle conditions, f is continuous on closed interval idea and differentiable on the open interval idea. Then the slope of the line passing through f of a and f of b equals the slope of some tangent to this curve at some point which first coordinate is in AB. Is in AB. Of course, if we multiply b minus a on both sides of this equality, we obtain this equality. Okay. When under this condition, in addition f of a equals f of b, then the difference of these two numbers is 0. So f prime of c equals 0. For some c in the open interval AB. In fact, we use Rawls theorem to prove this theorem because we consider a new function constructed by this function f minus this function L. So the difference of these two functions whose height will like this. And in fact like this. So we prove this theorem by using that theorem. And this theorem is almost clear because under this condition, f always has a maximum and minimum. This is the extreme value theorem. If maximum and minimum are equal, then the greatest one is this number, and the smallest one is also this number, then f must be a constant. I mean, whose graph is this horizontal line segment. Okay. Then this condition, this result holds because C can be any point in AB. On the other hand, if the maximum is greater than this one, then the maximum must occur inside this interval by Fermat theorem. And the differentiability of f, this condition, whose derivative at the okay, local extrema must be 0. Okay. So this theorem follows from extreme value theorem and the Fermat theorem. And using that, this one is proved. And also using this, by letting FA equals FB, we obtain Rawls theorem. So these two theorems, in fact, logically equivalent. They can, okay. Let's see some examples. Example 2. Prove that the equation x cubed plus x minus 1 equals 0 has exactly one real solution. In fact, y equals x cubed, whose graph is okay. This curve stands for an increasing function, increasing, not decreasing, increasing function. And y equals x also increasing. So the sum of these two functions, whose graph will this is y equals x. And y equals x cubed. Also, negative. So by a superposition property, this is the graph of y equals x cubed plus x. Minus 1 means that we shift this curve down by 1 unit. Therefore, exactly one intersection of this curve and the x-axis. This means this equation has exactly one real solution. Because y equals x cubed plus x minus 1, whose graph is this curve, and y equals 0, whose graph is x-axis. Okay. Then this one equals 0 means we have to find the points, which is a common point on these two curves. One is horizontal line, another one is this curve. Okay. So intuitively, this result is true. But how to apply this theorem, Rolle's theorem or mean value theorem, to prove, to show this statement? If this is not x cubed, for example, we replace this one by sine x plus x minus maybe cosine x. So this example is very simple because we can easily to check the result by an intuitive way. Okay, let's prove this. Usually exactly means the number of the solutions, real solutions, equals 1. Equals 1 means at least 1. And at the most 1. The number of the real solutions, the number we use this, and the number of solutions, and at least 1 and at most 1, therefore, exactly 1. OK， 那我们要证明恰有一个实数解的时候，我们就证明解的个数至少有一个，就是大于等于1的这么多个实数解，也证它至多只有一个，它至少有一个，至多有一个。根据三叶律呢，这大于等于跟小于只能有一个成立。如果大于这个小于跟等于就不成立，如果小于呢大于跟等于就不成立，所以只好靠这边呢，就是这样。So to show the number of real solutions or to this equation is exactly 1. We have to show, we can prove this by showing the number of real solutions is n. N at least 1 means greater than or equal to 1, and at most 1. N is less than or equal to 1. Because by trichotomy, if n is greater than 1, then n cannot less than 1 or equal to 1. If n is less than 1, by trichotomy, this and this cannot be happening. Okay, so n equals 1. Well, let's do this. Usually, at least 1, we use the intermediate value theorem. And if most 1, we use mean value or rolls. Okay, let's do it. In order to show this equation has at least one root, real root, we let a function f be x cubed plus x minus 1. And we have, if x equals 0, this is minus 1. If x equals 1, the value is 1. And then this number is less than, is negative, less than 0. And this number is positive, greater than 0. Therefore, the number 0 is an intermediate value of this function. So by the intermediate value theorem, 0 is an intermediate value of this function. Okay, fc equals 0 means c cubed plus c minus 1 equals 0. This number c can be found. So for some c in the open interval 0, 1, this shows that